In this session, we are starting a new topic, which is relations and functions. And today, we want to actually understand the very basic concept behind relations and functions, right? Okay, so we actually approach it in a practical way where we look at examples, and then the examples I'll be looking at are in this table. Yeah. So in here there are three tables, right? So try to get the relationship right in the tables. We from the first one to the last one. So let's look at the first one. So let's call these guys, the guys that are at the top there, let's call them the X values, and the one at the bottom, let's call them the Y values. So the game that we are going to play over here is to try to see if among the X values themselves there's a relationship, if among the Y values there's a relationship among themselves, and if among the X and Y there's a relationship in that too. So see, when we're talking about relationship, we are saying that if we take the first two, right, the relation between them should be the same for all of them. If we take the first two x values, like the one and the two in the first table, we need to what relation that the relation that we draw over there should be the same from when you're taking two and three, three and four, four and five, successive terms, right? Or it's the same thing for apply for y or any relationship. Anytime you draw, you're able to come up with a relationship or relation, make sure it draws throughout, right? Yes, that's what you have to do. Now, let's look at the first one. So, the first one, let's talk about the x value. Among the x value, so 1 to 2, right? 1 to 2. What is there any relationship? How did we get to 2? So, I think someone would say, okay, we added 1. So, maybe someone would say we did plus 1, then we got 2, right? Someone would say, okay, we did times 2, then we got 2. Okay, so now let's see which one work. Now, if you take the next pair, if you do plus 1 to get 3, right? Yeah, that's fine. That's okay. But if you do the times 2, we should get 4, not 3. So it means that the times 2 1 relation doesn't work. It's rather plus 1. So let's continue and see 3 plus 1 we get 4, 4 plus 1 we get 5, 5 plus 1 we get 6, 6 plus 7. So now, meaning that there is a particular relationship among the x values. That's what we basically call, like, at the very basic term, a relation. Whenever you draw a relationship among values or between one set of values and another, then you are building what? A relation. Let's talk about the y values. Now the y value 30 to 34 is obvious, right? We added 4 in each case. 30 to 34 is going to be 30 plus 4. We added 4 to get 34. We added 4. When you add 4, you get 38. When you add 4, you get 42, 46, 49. So you see that there's a relationship running through every item among the y values. Okay, then the next challenge is what about the x and y? So let me clean this thing properly so that we can see that very well. Now let's talk about the x and y. So if you take the first one, 1 and 30. Okay, so 1 and 30, what did you do? Is it 1 times 30? 1 times 30 will give us this, right? Then you should wait for the 1 times 30. It should give us, nah, it doesn't work. 2 times 30, it doesn't work. It doesn't work. So meaning that relation is not working. What other relationship? So someone will say plus 2 and then everything times 10. So if you do plus 2, everything times 10, then if you do plus 2 here, everything times 10. Now it doesn't work because 2 plus 2 is 4, 4 times 2 is 40, it's not 34. So we are finding it difficult to draw a relationship among the x and y values. Do we see that? Yes, that's so there's no relation among the x and y values, and then but there is a relation among the x values themselves, and there is a relation among the y values themselves that we've seen that. Yeah, that's the analysis of the first one. Let's look at the next one. Let's look at the second table. So again, the top one are going to be our x values, and the bottom one are going to be our y values again. Now, among the x values, is there any relations? 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8? Yes, as this first one, right? There's an addition of 1 in each case. Addition of 1 in each case before you get to the next one. Let's get to the y values. Now, on y values, I have 2 to 3 to 5 to 9 to 17 to 33 to. Wait, what's happening? Okay, 2 to 3, right? Someone will say plus 1. Okay, then we get 3. Should we do the plus 1 to get? No, plus 1 should give us 5. But why is it giving us 5? So, meaning the plus 1 relation is not valid. The plus 1 relation is not valid. Then which one? Is it? What about if you multiply this one by 2, right? I will get 4. And then the result I get, if I do minus 1, I'll get the next one. That will 3. So let me try to see that. If I multiply this by 2, right, I will get 6. 6 minus 1. Then will give me what? 5. Yeah, that's work, right? This thing times 2, that's 10, right? 10 minus 1, that will give me 9. Like, so let's do this one. 2 times 9, that's what? 18, right? Minus 1. That gives us this. So that's the relation. So among the y values, right, you have to multiply the previous value by 2 and subtract 1 to get the next one. So 17 times 2 is 34. 34 minus 1 is 33. That's basically that's what that one is about. So that's the relation. We're able to get the relation among the s and y. Now let's see if between the s and y values do we have any relation. Let's see if you have any relation. Let me clean this in properly. So 1, right, and 2. So I think we do plus 1 to get this, right? But 2 plus 1 here, plus 1 will give us this. This one, plus 1 will not give us, so it's going to be plus 2. It doesn't work. This one, yeah. So that relation is not working. So you can try different ones, right? So yeah, but you understand what we are trying to do. We're trying to see if you can find a relationship among the s value, among the y values, and between the s and y values. So it may not always be the case for all of them. You may have a relation among all the s values, you may have relation among all the y values, but you may not get between s and y. Sometimes you may get between s and y, but that's not the case. Now let's call this one to again our x and call these guys our y again. 1 to 2 to 10 to 4 to 5 to 6, right? 1 to 2 to 10 to 4 to 5 to 15 to 12. What? 1 to 2. Now 2 to 10, right? That's huge. And we get back to 4. Now there seems not to be a logical reason, logical relation, right? From one value from the previous value to the next among the s values, right? Yeah. So yeah, we leave that. Now let's go to the next, the y value. So there's no relation among the x values. We have established that. Now let's go to the y values. In the y values, 5 to 6 to 14 to 8 to 9. So 5 to 6, right? What's the difference? I think it's plus 1. So 6 to 14, that'll be what? 6 to 14. That's plus 8. Yes, that's basically plus 8. Oh, okay, that's huge. And then 14 to the next one. 14 to 8, that's minus. No, I think the relation is trying to. So yeah, you can try to find a relation yourself, right? But then I seem not to find any relation among the y values among themselves. Then there should be a relation, right? Among these 1 to 1 to 5, right? I can do plus 4. 1 plus 4 will give me 5. This one plus 4, right? 2 plus 4 will give me 6. 10 plus 4 is 14. 4 plus 8. 4 plus 4 is 8. 5 plus 9 is, yeah. I think, yeah. So there seems to be a relation here. Wait. 5 plus 15 plus 4 is 19. 12 plus 4. I think, oh, this one is a mistake. Yeah. It's 16. It's supposed to be 16. And 8 plus 4 is supposed to be 12. But you wrote 13. It's 16. Wow. Sorry about that. Yeah, but then that's it, right? You've got a relation among the between the x and y values, but there's no relation between the s values themselves and among the y values themselves. But between the s and y values, there's a relation of plus 4, right? 1 plus 4 will give you 5, like that. So there's a relation like that. Let's go to the bottom one, the last one, the last table. Again, the top one are going to be our x and the bottom are going to be our y. Now, is there any relation among the x values? 1 to 2 to 10. Okay, yeah, I think we are using the same there. So, meaning definitely there's no relation among the top one. What is the bottom one? 4 to 600. Wow, 123, 78. You can try and find a way, but I believe that there's no relation among the y values from one sequence to another, from one previous value to the next one. There's no relationship. But let's try to see if it s and y. 1 to 3, that's plus 3, right? 2 to nah. That's huge. And 10 to 103. There seems not to be any relationship anywhere at all, not among the s values themselves, not among the y values themselves. And there's no relation between the s and y values. So what's that? There's no relation, right? Yeah. So basically, relation is just mostly about trying to find a pattern, right, between values, between a set of values. So you have a set of values, that's the x values, and the y values on the other side. And then are we able to draw any relationship among the two? If there's a relationship among the two, the two sets, then that's a relation. Anytime there's a relation, right? Anytime there's a relationship, anytime there is a connection for each y, for the y value to the x values, then you have a relation. Among the y values to fine, among the x values to fine, right? But then we know that we have established that there should be a relation at least. And that's all the as the word already say, right? Relation is relation. That's relation. That in the next session, we'll look at what functions are. So function is a subset of relation, right? Relation is the boss, and function is under it. So now we'll take time and then see what functions are in the next session, because that's the major concern in this particular topic. See you in the next session.